Good morning, class. Let us start with the next chapter. Chapter 13, Exponents and Powers. Exponents and Powers. Let us start with the class with one of the tasks given by one of my friends. He said that I have to write 200 times in multiplication. He gave me a very easy task. It seems very easy. He said that I have to write 200 times representing itself. Means 2 into 2 into 2 into 2 into 2 into 2 into 2 up to 100 times. Now tell me yourself, representing 200 times is easy task or difficult task? Yeah, it is a little bit difficult task. It's not easy. Because writing 200 times, it's not easy in a way. If you are fluent, then only you can write. Maybe the disadvantage of writing in this form, maybe you miss two of the numbers, maybe again and again you are calculating, again and again you are counting, time consuming, right? So to avoid such labor and hard work, we have a chapter called Exponent and Powers. Why? Because now see the magic. What I am going to do, I will represent this in a simple form, 2 raised to power 100. The task given by my friend was this. He asked me that I have to represent 200 times. I have represented 200 times. This form is known as exponential form. This form is known as exponential form. Why it is known as exponential form? I'll tell you, because it has 100 as an exponent, and this 2 is called base. So do remember, if such task is given to us, we can represent it in this form called exponential form. This is what is the advantage of exponent and powers. Why we use exponent and powers? Because it makes our presentation look presentable, and it saves our time, and it's very easy to represent. Yeah, there is no hard work. 2 raised to power 100. How do we pronounce this? We pronounce this as 2 raised to power 100. This is how we will pronounce, this is how we'll say that it is 2 raised to power 100. Are we clear with this? So this is called exponential form, and this form, this also means 2 raised to power 100, and this form is known as expanded form. It is known as expanded form because we have expanded. So this form is known as exponential form, and this form is known as expanded form. So any number in exponential form has two things with it. One is base, another is exponent. Anything raised, this anything is called base because it decides the factor. It's a deciding factor, and this exponent is deciding that how many times this base will be represented. So what is exponent? Exponent is shorthand notation of representing numbers. If we have to represent a number representing bigger numbers, so I'll say bigger numbers can be represented in exponential form, and it has two things, base and exponent. So this is called base, this is called exponent. Now you might be thinking the name of the chapter is Exponent and Powers. What about powers? Yes. So basically power, if I talk, this base and exponent together is known as power. This base and exponent together is known as power. Power here means what value you will be getting on considering 2 raised to power 100. That decides the power. What is the power of 2 raised to power 100? That is what power means. Another name of exponent. Exponents are also known as power. That's not a problem. We call it, they are interchangeable terms. But understand, base plus exponent together is known as power, and your exponent is also known as index. Another name of exponent is index. Do remember, index. We also call them index. 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 Are we clear? So basically, again I am repeating, base and exponent form is called exponential form. This form is known as expanded form. How do we pronounce this? 2 raised to power something, and this together is known as power. Another name of exponent is index. Are we clear? This is one of the basics of exponent and powers. Next is laws of exponent, but before that we'll do the application based on this. For that I request you all to please open your books on exercise with your exercise 13.1. Let's do it. First question, exercise 13.1 will be doing. First question, we'll see what is the first question. First question is, find the value of 2 raised to power 6. Question number 1, find the value of 2 raised to power 6. Find the value of 2 raised to power 6. What do you mean by 2 raised to power 6? If I am talking about 2 raised to power 6, first of all, this form is known as exponential form. Right? This form is exponential form. Why? Because we are having base as 2 and exponent as 6. That is why it is known as exponential form. What do you mean by 2 raised to power 6? Understand. 2 raised to power 6 means, please listen to my wordings very carefully, it's very, very important. 2 raised to power 6 means this 6 as an exponent is asking the base 2 to represent itself 6 times. Again I am repeating, this exponent 6 is asking base 2 to represent itself 6 times. Okay, representing itself 6 times means 2, 2, 2, 2, 2, 2, 6 times. And here representing means multiplying with itself. This is very important. Are we clear? So 2 raised to power 6 means we'll be writing 2 6 times and multiplying with each other. 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 2 32, and 32 into 2 is 64. So what is the answer of 2 raised to power 6? 64. Are we clear? This is how we have to do the first question. Any doubt anyone is having in this question? Question number 2, express the following in exponential form. Express the following in exponential form. Express in exponential form. What do you mean by exponential form? Whenever we talk about exponential form means there should be a base, there should be a exponent. I'll be doing first part, very easy. 6 into 6 into 6 into 6. Now 6, 6, 6, 6. It means which number is represented here? 6. The number which is represented is called base. It means base is 6. Clear? Because 6 is represented here. How many times it is being represented? 1, 2, 3, 4. It means 4 is the exponent. What is the answer? 6 raised to power 4 is the exponential form of this. Which number is represented? 6. How many times represented? 4. That is what exponent is. And see how you will be writing. It's very, very important. Base. Don't directly attach it. Take it little bit above like this. And don't do it with 6 you are writing here and 4 you are writing just far away like here. No, it should not be like that. Just above. And do remember, you will not even write. I have seen students writing like this even. That is also wrong. This is also wrong. This is the absolutely correct representation of exponential form. Are we clear? Second part I'll be doing. Let me take sixth part. A into A into A into C into C into C into C into D. You might be thinking, sir, earlier you were talking about the same number representation. Yeah, but what is difference? There is no difference in this. It's very easy. Here, basically, if I talk about, there are 3 three bases. A is also represented, C is also represented, and D is also represented. So there is no problem. It can be any number of bases. There can be any number of bases. There is no limit on bases. So A as a base, okay, A as a base, how many times it is represented? 1, 2, 3. So 3. Next, because multiplication is there, we'll keep the multiplication only. A, C, C, C. C is represented base, how many times? 1, 2, 3, 4. Okay, 4. And left with D. D is represented one time only, so we can keep. This is what the answer is. Okay, you can write this thing as this also. This is also correct without putting multiplication sign, because it is quite understandable from here that A raised to power 3 is multiplied by C raised to power 4 multiplied by D. So this and this thing is equally right, presentable. We can write like this also. Are we clear? Very, very important chapter. Means this is the basic chapter. Without this means in further classes you will not able to do anything, because multiplication, subtraction, polynomials means so many things are there you have to. It's very basic and very, very important chapter. Next, question number 3. Express each of the following numbers in exponential notation. Earlier, this form is given, expanded form. Now the value is given to us and we have to convert that value into exponential form. Question number 3. We'll do question number 3. Let's understand. So I'll be taking first part, question number 3, first part. Represent again in exponential form. Now, understand the question. First part is this 512. How you will represent? Basically, for representing exponential form, we use two methods. One is prime factorization. Another is square root method. If we have to represent any number in exponential form, we have two methods, prime factorization or square root method. Square root method is applicable only for square numbers, the numbers which are perfect squares, like 4, like 9, like 16, like 25, like 121, like 196, 625. They are perfect squares. So only for those numbers the square root method exists. For rest of the numbers, the best method is prime factorization method. What is prime factorization method? In prime factorization method, you do the prime factorization of the number. For example, this number is there with us, 512. I do the prime factorization. So it's an even number, so I'll be considering 2. Definitely it will be divisible by 2. 2 is 256, right? Then again, I'll be doing, it's 1, very good. It's 4, 148. Sorry, 128. Then 64. Then 32. Then 16. Then 8. Let me rub this. Then 2. Then 4 4s are 2 2s are 4. Then 2 1s are. So how I can write? I can write 512 as 1 2 3 4 5 6 7 8 9. Okay. 2 into 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 2. So 2 into 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 2. That is 9 times. So 2 is represented how many times? 2 raised to power 9. So 2 raised to power 9 means 512. If you multiply this, you'll be getting 512. This is what is the representation, exponential form of representing numbers. Are we clear? So you'll be following the prime factorization method for solving such questions. Any doubt anyone is having in this exercise? Means in this question. Next, question number 4. Identify the greater number and wherever possible in each of the following cases. Now what we'll do, we'll find which number is bigger. Okay, maybe exponential form is given to us. So using exponential form method, we'll be solving that which number is greater. Means now we are talking about the next topic, comparing of exponential forms. Okay, comparing exponential forms. So let's do it. Identify the greater number wherever possible. First, I'll see question number 4. 4 raised to power 3 or 3 raised to power 4. Directly by asking or seeing the exponent, we can answer. More the exponent, definitely more will be the value. But in this case, we need to take care of this also. Directly we can solve because it's not a cumbersome problem that we are not able to solve. So let's solve it with another method. Let's have it. Let's do it. Basically, if I talk 4 raised to power 3 means 4 into 4 into 4, or 3 into power 4 means 3 into 3 into 3 into 3. 4 into 4 16, 16 into 4 is 64, or 3 into 3 9, 9 into 3 27, 27 into 3 81, which is bigger, 81. Therefore 3 raised to power 4 is greater than 4 raised to power 3. This is quite understandable since the exponent of this one is 4. That is why the answer or this particular term is greater, right? So directly we can say, but in same cases that is not possible also. I'll show you one example. 1 raised to power 100 or 2 raised to power 2, which is bigger. You might be thinking, sir has given us the rule that the bigger exponent means bigger term, right? But see the exponent. 1 into 100, 1 raised to power 100 means writing 100 times. 1 into 1 into 1 into 1 into 1 up to 100 times. If you will do it, what is 1 into 1? 1 into 1, 1 into 1. Even if you write 100 times, answer is 1. But what is 2 raised to power 2? 2 raised to power 2 means 2 into 2. So 1 or 4, which is bigger? 4 is bigger. So here the exception is there. So you need to be very careful with such thing. Directly don't jump on the conclusion. We need to be very alert. We need to be very vigilant. I'll do one more part. Let me do the fifth part. 2 raised to power 100 or 10 raised to power 2, or directly we can see 2 raised to power 10, 10 raised to power 2. Definitely if I talk about 2 into 2, 2 raised to power 10 means 1024. Or this means 10 into 10, that is 100. I'll tell you the importance of this. If you would have seen in our mobile data, we got 1 GB, right? In mobile data, byte is there. Yeah, bytes you get, kilobytes, gigabytes, megabytes. Understand what is gigabyte? 1 gigabyte is 1024 megabyte. This is very, very important. So hence 2 raised to power 10 term is very, very important. Are we clear? Are we clear about this? Okay. So question number 5. Express each of the following as the product of powers and their prime factors. Almost same question. No change. Just see the change. Question number 5. Express each of the following as the prime factor. Question number 5. I will be doing first part. Again, we have to represent the following as the product of powers of their prime factors. It means only prime number should be there. I am considering first part 4, 6, 4, 8. Again, prime factorization. Since it's an even number, I will be taking on this 3 to 4. Again, I will be considering on 2, 1, 6, 2. Again, I will be considering on this 81. Now, 81 is not an even number, so I will try on 3. Yes, 3. 27s are, it's 81. 29. 3 into 9, 27. 3 3s are 9. 3 1s are 3. So what we got? 648 is equal to, we write 2 into 2 into 2 and 3 into 3 into 3 into 3. So 2 into 2 means 2 into 2 into 2, 2 raised to power 3, and 3 into 3 into 3 into 3 means 3 raised to power 4. So this is what is the representation in terms of power of prime factor of this given number. Are we clear? Will you be able to do this sort of questions? Very easy to do. Very, very easy. Next, question number 6. Simplify. Why I am not doing each and every part? Because you have to try. Until and unless you will not try, you will not get. I will do one more part of this question because you might find this part very difficult on first look, but it's indeed very easy. Fourth part of question number 5, it's 3600. You might find this question very difficult. but it's not. Trust me on that. Again prime number, I'll be doing this. Again prime number, I'll be doing this. Again prime number, again even number, I'll be doing this. Again even number, I'll be doing this. 225. Now 225 definitely we know divisible by 45. Yeah, again we'll be doing 5 nines are right, 3 threes are 9, 3 ones are 3. So 3600 can be represented as 2 into 2 into 2 into 2, 5 into 5, 3 into 3. So I can write 2 raised to power 4, 3 raised to power 2, 5 raised to power 2. Any doubt anyone is having with this representation? Clear with this? So this is how. Just do the prime factorization. You need to be very careful with the prime factorization because you missed one error, one multiplication error. The whole answer is wrong. You're not able to. So you need to be very fluent. You need to be very careful while representing. Are we clear? Any doubt anyone is having? So let's move on to question number 6. Simplify. What do you mean by simplify? What do you mean by simplify? Simplify means you have to solve it. You have to get the answer. Okay, that is what simplification means. You have to simplify. Means you have to do each and every part with the simplification so that it is understandable. Answer must be understandable. For example, somebody is not very inquisitive with maths. He has no idea what is there in exponent and parts. If you write 2 raised to power 3, the person is not able to understand. But if you write 23, the person will understand, yes, it's 23. So that is what simplification is. So in simplification, we write simple answers which are understandable by anyone. Okay. So first part I am doing question number 6. Simplify. Okay. I am doing 2 into 10 raised to power 3. 2 into 10 raised to power 3. Basically, this form is known as standard form of exponents. This is called standard form of exponents. We'll discuss this concept in exercise 13.3. For that particular time, have patience. So this is standard form. Now, how do we represent 2? As it is 10 raised to power 3. 10 raised to power 3 means this 3 is asking 10 to represent it how many times? 3 times. Very good, I know you are giving the answers. 10 into 10 into 10 into 10. Now 2 into 10, 20. 20 into 10, 200. 200 into 10, it's 2000. What is the answer? Answer is 2000. Are we clear? This is what simplification is. I'll try to do another part, the difficult one. If you feel so, this part is easy. I'll try 6th part or maybe 7th because 2 raised to power 4 into 3 raised to power 2. Very easy. 2 raised to power 4 means 2 is represented 4 times. 2 into 2 into 2 into 2. And 3 raised to power 2 means 3 is represented 2 times. Okay. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 3, 48. 16 into 3 is 48. And 48 into 3. 48 into 3. What is the answer? Yes, it's 144. Absolutely right. It's 144. So 2 raised to power 4 into 3 raised to power 2 is 144. Are we clear? Any doubt anyone is having in this concept? So can we do it? Question number 7. Again, simplify. I'll be doing first part. Minus 4 raised to power 3. Before that, please write down few points. Please note down this important points. I'll be writing. If base is negative, why I am doing so? You would have observed till now the base was not negative term, it was a positive integers we are talking about. We are talking about integers, it was positive integer. But now the base is a negative integer. In case of negative integer, when will be the answer negative? When will be the answer positive? I am giving you one mantra, one golden rule. By this, immediately by looking, you can know. Answer may be anything, but you know whether the positive or negative sign will come. That is very important. If base is negative, exponent is an even number, result is always positive. Result is always positive. Second, if base is again negative but exponent is an odd number, result is always negative. It's very important. You have to understand. Result is always negative. Why so? See, if base is negative, for example, I am taking a brilliant example, 2 raised to power minus 2 raised to power 4. Minus 2 raised to power 4 means minus 2 will be represented 4 times. Yes or no? We'll be doing this because negative. Now, this minus will be cancelled with this minus. This minus will be cancelled with this minus. Hence, whatever the result you will be getting, that will be positive. But see in this case, what will happen in this case? Minus 4 raised to power 3. Minus 4 raised to power 3 means minus 4 into minus 4 into minus 4. Yes or no? Minus 4 into minus 4. Minus minus plus. Minus 4 into minus 4 is 16. And 16 into minus 4 is plus minus minus, that is 64. So have you observed one thing? If base is negative, power of exponent is an odd number, result is always negative. Hence proved, this is also proved. Are we clear? Any doubt anyone is having? So this is only the important thing in this to understand. Are we clear? Next, so will you able to do this part? Let me do second part because it sounds bit different, but it's not. Maybe students are having confusion in this part. Let's do it. Minus 3 into minus 2 raised to power 3. Now you might be thinking minus 2 raised to power 3, base is negative, exponent is odd number, result will be negative. But this minuses will also include it. So how I will represent it? Minus 3, minus 2 into minus 2 into minus 2. Now minus 3 into minus 2 is 6. Now 6 into minus 2, it's minus 12. Minus 12 into minus 2, it's 24 because minus minus cancel. Why this minus minus? Why the result is positive? Because here 3 negatives are there, but this negative makes the 4 negatives. 4 negatives means positive, even, and hence the result will be positive. Are we clear? Last question. Last question is question number 8. Very important. Question number 8. Let's see the question number 8 immediately, everyone. Very easy. We'll see question number 8. It states that again, comparing that part. We have to compare. Yeah? Which is greater, which is smaller. Again, question number 8. Again, compare the following. I'll be taking the first part. 2.7 10 raised to power 12 or 1.5 10 raised to power 16. Now, very easy to do, but very important part to understand. Again, this form is known as standard form. Again, I am telling you, this is called standard form. Again, this number is represented in standard form, which we'll do in exercise 13.3. Understand? This is exponential form, right? Leave the exponential form. Time being, let's see this number. Here 2.7, here 1.5. So according to this, this must be greater. But let's move. So right now, this is bigger. Let's move on to exponential form. 10 raised to power 12, 10 raised to power 16, which should be bigger. This should be bigger. That is why 1.5 into 10 raised to power 16 and 2.7 into 10 raised to power 12 is bigger. So as compared to 2.7 10 raised to power 12, 1.5 10 raised to power 16 is bigger because they are almost same in decimal form. But this 10 raised to power 16, exponent 16, here exponent 4, there is a difference of 4, means 10 raised to power 4. 10 raised to power 4 means difference of 10,000. So this term is bigger compared with this. Are we clear with this concept? So Directly don't jump to the conclusion. Just observe. Main thing is exponent. Bigger exponent, bigger value. Next part. I remember 10 raised to power 13 or 3 into 10 raised to power 17, I believe. Yeah, 4 into 10 raised to power 14 or 3 into 10 raised to power 17. Exponential form, limit again standard form. 3 and 4. 4 is bigger, so this must be bigger. But 10 raised to power 14, 10 raised to power 7. Since base are same, we can jump. We can directly compare. It's very easy to compare with the bases same. 10 raised to power 14, 10 raised to power 17. What is the difference? 10 raised to power 3 difference is there? Yes or no? So difference of thousands. Hence, which is bigger? Absolutely. As compared to 4 into 10 raised to power 14, this is bigger because here we are having bigger exponent. So you can write because exponent 17 is greater than exponent 14. You have to write the reason also. Are we clear? Here also you can write the same reason. Exponent 16 is greater than exponent 12 in the above condition. Are we clear with this? Very easy concept to do. Very easy chapter, very comfortable chapter, but indeed to remember, very important chapter. So again I am repeating once again, let's recap what we have done so far. This is called exponential form. With exponential form we are having a base, we are having an exponent. Exponent another name is index. Base and exponent together is called power. This is called exponential form, and if we expand, that is called expanded form. Clear with this? Any doubt anyone is having? Another thing, for representing or simplification we use two methods, prime factorization method or square root method. Square root method is applicable only for perfect squares and prime factorization method is applicable for any number. What we have to do, just do the prime factorization and then represent the numbers in the following method and then exponential form. Are we clear? Any doubt till now? We'll meet in the next video with the very important concepts, laws of exponent. Till then, take care and have a nice day.